So we probably need to talk a little bit about what that was that we just saw. That is my '88 Toyota pickup throwing a rod right out the side of the block. I was heading north on 95 in Virginia, just got gas at 104, and I was pulling back on the highway when it let go. And the engine was hurting. We'll talk about that here in a second. I knew exactly what it was, so that's why I shut the key off so quick, which shut the dash cam off basically right as stuff was happening. So that's that. So I got it towed home and ended up taking my 4Runner on that trip instead. So when I bought this truck, the engine was already a little bit hurt. The previous owner's son had rolled the truck. It ran upside down in a ditch, best I can tell, because it's EFI, so it'll run upside down. But a lot of the bearings and surfaces look like they'd run without oil. And I know the guy was pretty meticulous with oil changes, so that's my guess there. It had low oil pressure. Then, over Christmas, I was at my parents' house. I was doing a little bit of off-roading. Went through a creek, hydrolocked it. Not like got the plugs wet, it sputtered and died. Like it sucked in water and stopped hard. So I got it running, pulled the plugs, drove it home, but it was steaming bad, like real bad, like James Bond smoke screen. You couldn't see, it was terrible. So I'd blown the head gasket. So I replaced the head gasket 4 hours from home at my parents' house. And when I had the head off, a TDC, piston number 1 and 4 are supposed to be even with the top of the block. 4 was like quarter inch down, so I knew I had bent a rod. But I had to get home, so I buttoned it all up. It ran fine. A slight mislet idle from lower compression, but it ran okay, so I just kept running. I ran it for about a month, and then this trip, obviously, it let go. And so that's that. Toyotas are, I'm a little bit defensive here, right? So, they make a good engine, but there's only so much you can do when it's got no oil pressure, bent rod, 3,000 RPM. I mean, yeah, so I killed it. Anyway, so in the rest of this video, we're going to be assembling that new engine and getting it back into the truck. So let's get to it. Hey guys, AlexMan here, back in the garage again, working on the pickup today. I got my block back from the machine shop. Let's take a look at it. So here's the block, freshly cleaned, bored and decked. Okay, as I'm editing this, I'm realizing we're missing a pretty important detail. This block is not the block that I just destroyed 30 seconds ago in this video. This is the block that used to be in my 4Runner. The 4Runner got a new engine from 2208 Performance, and this is the core. Luckily I hadn't shipped it back yet, so I was able to have it machined locally, so I can assemble it here at home. All right, let's flip this guy over. Decked the block, bored it to match the new pistons, chamfered it of course. Looking sweet. Also had the crank looked at. It was magnafluxed, it was measured. They did not need to grind the crank, so they just polished the journals. Had it all cleaned up, so I'm waiting on new plugs to go in here. I was going to reuse the galley plugs. I didn't really look at them until I went to put everything back together and realized, oh look, the threads are messed up. The smaller ones are the crank galley plugs. 2 of them are kind of messed up. 2 of them could be reused, but they're slightly damaged, so I just bought a new set of those. So plan for today is get the crank into the block, plastic gauge them, because I don't have real measurement tools, so just going to verify that everything looks good. Maybe get the pistons in. I won't have the galley plugs yet, but those are still accessible even once the crank and rods are bolted in, so I can just not put the oil pan on until I get the galley plugs in. Alright guys, making progress. So I just finished cleaning the whole block. I went through and chased all the threads. Not all of them. I didn't do the pipe threads for the oil pressure sender or any of the kind of off threads, just because I don't have a tap or a thread chaser for the British standard pipe threads. And also there's some holes that just don't get used and they've never been used and they're all rusty, and I didn't bother with those either. But checked all these threads. There was a couple that were messed up. I helicoiled them and got those ready to go. I didn't do the ones on the back of the block just because I can't get to those right now with it being on the stand, but I can do those later. All the threads checked out good. So now I'm getting ready to plastic gauge the main bearings. They're standard size bearings, and I didn't cut the crank or anything or grind the crank, so they should be just fine, but just kind of a sanity check. Not a bad idea, I don't think, so let's go ahead and do that. Plastic gauge will be used to measure the bearing clearance between the crankshaft and the crankshaft bearings. Plastic gauge is a small, soft plastic material which is placed between the two surfaces to measure the clearance between them. It starts off cylindrical, then as the parts are assembled, it's smushed between them. The thinner it's smushed, the wider it smushes out. The parts can be disassembled, then the plastic gauge width compared to a key to determine the clearance. It's not as accurate as micrometers, but it gives an idea of whether you're in the ballpark or not. Okay, real careful to drop this down into here nice and straight. Now I don't have the thrust bearings in there. I'm just going to visually center that. Alright, so here's the plastic gauge. It's this little hair-like piece of plastic. Comes in these little paper things made by Clevite. They're also made by Sealed Power because I bought the wrong size. Because the guy said, do you want the bigger or the small one? And I said I need the smallest one. But the smallest one that they sold was not the one I needed, so I had to go back to a different store and get the correct size. So we're definitely doing some small gaps in here. So we got the 1 to 3 thou plastic gauge. And we're just going to cut this with some scissors to the right width to fit into our journals there, and bolt these in, and then take them apart and measure the gap. Then we'll consult with our Bible to find the torque specs there. Main bearing cap, 76 foot-pounds. Alright, so here it is after we've taken it apart. And I would say we're right around 2 thou. So looking in here, we're right in the normal range, 1 to 2 thou clearance on the main bearings. 3 thou is the max, but 3 thou would be acceptable apparently. Plastic gauged all the main bearing journals, and they all came out at 2 thou except for this one, which came out like somewhere between 2 and 3, closer to 3 thou, but that's still within the acceptable range. And so yeah, now we're going to do the rod journals. So we checked all the rod bearing clearances with the plastic gauge. We checked all the main bearing clearances with the plastic gauge. Now we're ready to drop the crank into the block there. So we just need to make sure everything's clean, clean up all the bearings and the journals again, just to be sure. We'll get some assembly lube in there and we'll lay the crank down in, and we'll be able to crank the main bearing caps down. this nice and even, nice and straight. And we want to be real careful not to knock those thrust washers out of position. Like butter. It's a new day, well, same project. But anyway, today we're working on getting the pistons on the rods, getting the rings gapped, and hopefully getting them all bolted on to the end of the block. So we got our rods here. Yesterday we measured all the bearing clearances, everything looked good. Got the rings here. So we're gonna start gapping these. Got one of the pistons here, and we already got one of the rings put down into the bore there for cylinder number 1. So we're gonna measure the ring end gap. If we're lucky, I don't have to touch them. So according to the ring manufacturer, we're supposed to have anywhere between 12 and 14 thousandths of ring end gap for the top ring. Well, actually for the top and the middle ring. 12 fits. 14 fits with the slightest amount of drag, so we're going to call that perfect. Go ahead and put in the second compression ring here. We'll square it up with the piston. 14 has just the slightest amount of drag, so we're going to call that perfect also. Oil control rings, those are supposed to have a minimum of 15 thousandths. Yep, 15 goes in, so we know we're good there. And we'll do the other oil control ring. 15 goes in. Alright, so now we just got to repeat this process for all the other bores and all the other rings. So we got pretty lucky there. All the rings measured, the gaps measured within spec, right out of the bag. So that's pretty cool. So now we get to start putting pistons onto rods, and then we'll start putting rings on pistons. So I took some pictures here while the engine was being taken apart, and what you can see up here is that's this notch in the piston right there, and the other part that you can see is this bump on the connecting rod, and that's these right here, and they're only on one side. So those, the bump there and the notch there, have to line up, and those also both point towards the front of the engine when it's all put together. So we gotta make sure we assemble it correctly. Alright, so we got all the rings on. Now we're going to position our rings. You know, you don't want them all lined up, you know, looking down from the top. You don't want all the ring end gaps to be lined up or anything. So we just got to make sure that they're gapped, you know, kind of mostly apart from each other. There's not a whole lot of science to this, so just kind of spread them out. They're going to move around once they're in there anyway, so no point in making them exactly perfect. Next thing we're going to do is spray some WD-40 in there. And we'll get our ring compressor. Loop up the cylinder wall. And now we will slowly lower the piston down into the bore. And now we should be able to just send it home. Alright, so we got the piston in the correct orientation with the notch towards the front of the engine, and we carefully lowered it down and guided the rod over the rod journal there on the crank. So now we're going to flip her over and put the cap on. Now we can go ahead and do number 4. Now we're going to torque down the rod caps to 51 foot-pounds. Alright guys, time to start putting the front end of this engine together. So we got our new timing chain kit here. This is the timing cover. I had this milled at the same time as the deck because this bolts to the front of the engine and the cylinder head actually bolts to the surface. So if you don't mill this at the same time as the deck or the block, then it'll be at a different height. So we got the timing cover there. So the 22RE is known to be a fairly reliable engine, one of Toyota's better engines, a lot of people say. Its Achilles heel is basically the timing chain guides. So this is one of the replacement ones. The factory ones are made out of plastic. So what happens is these get brittle, well, the plastic ones do, and they break. And the place that this sits is right here when the engine's all put together. But what happens is once this is gone, all the little pieces fall to the bottom of the pan. That's no big deal, they're just plastic. And now the chain is rubbing on the inside of this timing cover. and there's a water jacket right here. And what happens is it wears through into the water jacket. Now all your coolant leaks into the oil and the engine overheats. So here's the kit that we're using. This uses a metal-backed guide, so it's actually got a steel backing plate to it, and then it's got the rubber, rub part there. So this is a much-needed upgrade for the Toyota 22 REs. Yesterday we got the timing cover and the timing set installed, oil pump and the water pump, and just a couple other little things bolted onto the side off camera. So the plan for today is to get the head bolted on with the cam and the rocker assembly out of the pickup. Those were in good shape last time I saw them. So hopefully they're still in good shape. Got to pull them out of the motor today. And get the oil pan and that all glued on and sealed up. So basically we'll have a long block at that point, and then it'll just be kind of cleaning up the intake and exhaust and the accessories, bolting them all back on, and then we can drop this thing in. So here's the motor that came out of the pickup, currently sitting in the bed of the truck. So we got kind of a rear engine deal going on here. It doesn't work that well. So anyway, let's pull the valve cover off and then pull the head off. Take a look at the cam and the rocker assembly. Hopefully we're able to just clean them up and swap them right over. There's a milkshake. Yeah. Alright, no obvious wear on the cam yet. So we gotta pull it apart and make sure. Dang it. So, freshly pulled apart. Obviously some grit got in there. That's not from running, that's just from the head coming off. We know that we threw the rod on number 4. So here's the piston from number 4. You can see it's kind of twisted the wrong way around. And you can see the valves have been banging into the piston there. That's not really good. And so yeah, pretty neat. So here's the head. Rockers all look to be in fine shape to me. Very nice. Very usable. Awesome. I'll have to pull them apart and make sure that the shafts are good, but last one. Oh yeah. All in good shape. No scoring. Great. This is a good usable cam. Well, I got all the parts cleaned up. Garage smells like brake parts cleaner like crazy. If you lit a cigarette in here, the whole place might explode. But anyway, time to start putting this thing back together. punch and centered guide by eyeball.
So here's the factory exhaust manifold. I just finished cleaning up all the threaded holes. There was actually a broken bolt in there and there. I got those drilled out and got the threads cleaned up. Was able to salvage them. Got that all done, and but this thing is warped. Even after like 5 minutes on the belt sander, I mean, this thing is still super warped.
Here's the same exhaust manifold after I got it back from the machine shop. They put it on their industrial belt sander and had it flattened out in about 5 or 10 minutes. You can see a tiny area that's still below flush. The machinist said it would take a very long time to take off enough material to flatten that out, and that a bit of high temp silicone sealant should seal it right up.
Alright guys, it's engine day. It's already 4:30 in the afternoon. We're just getting started, but that's because I was waiting on my last part to arrive. That's this right here, the rear main seal. I thought I had one in stock, you know, in my gigantic order parts, but I don't, or didn't. So, got to put that rear main seal on, flywheel clutch, and then we're dropping this baby in. Let's try this again. Alright, so that wasn't too bad. It was really maybe a 10-minute delay having to pull the engine back out. It wasn't even seated yet, so not a huge deal. So to pull it back out, pull the clutch and flywheel off again. So if you saw that happening the first time you watched it through, leave a comment down below. I'm just curious how many people actually saw that, even though I didn't. So. I can hear the fuel going back to the tank. Let's check for fuel leaks. Looks good. Guess we'll try to start it. We're getting any oil pressure. Alright, so there it is. Started right up. Had a problem with oil pressure, but I think it was just the gauge because I jiggled the wire, restarted it, and then everything worked just fine. So pretty sure that was that. It's been fine ever since, so everything looks good with that. I drove it to work yesterday, and it ran perfect all the way there. So far I got no leaks, I got no smoke or anything. Everything looks great. It's nice and quiet and smooth, so very happy with it. But the more important question is, will it do a burnout? And of course with that limited slip diff, will it spin both tires? Maybe we should do a better one. Miss that smell. Yeah, I'd say it does burnouts. And the place that this actually sits, when the engine's all assembled,